This is the first such a collaboration in Poland using the competences of both companies. You are about to hear a talk entitled The Use of 3D Scanning in Simulation Modeling. I would like to invite to the stage a Director of System Implementation and Digital Twin Department at CAD-Vision Panowa Group, Marcin Szewczyk. Again, I would also like to invite to the stage the President. Yeah, the President of InterMarium, who is also a head of our engineering team, Dawid Dąbal. They are together present an inspiring case of utilization of 3D scanning to model and simulate the whole manufacturing process at the Plastivaloire Group Gliwice facility. I wish you a successful reception to the presentation. The stage is yours.
Okay, hello. My name is Marcin Szewczyk, and for nearly 20 years I'm working at Panova. I have been implementing system to help companies digitize their process. Yeah, and today I will short presentation where I will introduce you to the benefits that 3D scanning can give us. Yeah, CAD-Vision belongs to the Panova, how I say. Panova is a group which is on the market from 1997, and from 1999 we started sell Autodesk application on Polish market. Today we are the oldest Polish reseller of Autodesk application. As a group, we are employed about 250 people and with about 25-30 people in a CAD-Vision branch. Panova provides commercial investment service in the field of design and construction, from the purchase of land for the management of finished facility. We have our design studio, which means Panova Studio, with about 60 designers. And our new technologies department, CAD-Vision, which I represented, is a strategic partner for Autodesk and a few another global IT company. We have our R&D center located in Old Market Square in Gliwice. Yeah, this is a beautiful place, like a Krakow. Really, heartily invites you if you want to see more. In our R&D center, we develop technologies to support solution of digital twins of enterprises, and we call it this like smart cities and smart factory. We have our training center, and we support our customer in 3D scanning, 3D printing, and we do post-processors for CNC machines. Yeah. Today, all modern enterprise wants to have a digital twin for their entry organization. Yeah? As we know, the real digital twin, to be a twin, it must reflect real time in our systems, all processes, all changes that are happening in the company. Yeah? That's why our company, for several years, has been working in our R&D center, how I said earlier, and do an aggregation of all digital threads to one global base. Yeah, this is very important to build a real digital twin of our company. Yeah. A very good software for such process and aggregate this or such process is, of course, the PLM system, which just connect people, process, data from the product life cycle and to the central information repository, how I say. Speaking of PLM system implementation, I want say we have a lot of experience and one of the largest Autodesk PLM in implementation in Europe. Yeah, this system called Fusion Management, and if you want, we can talk about this later in a few yeah. But sorry. Oh, okay. Now I will show such a process looks like using the example of the plastic plant in Gliwice. How we can start a build digital twins. This is what I now show you. After this implementation, this plant in Gliwice from tier 1 become to be an OEM developer for WAG Group. Yeah, FPG, Fabryka Plastików Gliwice. Yeah, FPG is a part of Plastivaloire Group, the big France group, which have the plants in throughout of Europe. Today we talk about the plant in Gliwice, which includes about 26 press and about 29 robots. On there on more than 3,000 square meter. Of course, this plant have assembly halls where they finished assemblies in the area about 600 square meters, and of course they have outdoor areas and warehouses for materials, semi-finished and finished products, of course. Yeah. This plant have some more key data which you can see here now. And a portfolio of products is for automation industries what they produced normally. Yeah. And so getting to the point, how we do it this to start to do a smart factory. Yeah. How we say first is the 3D scanning of factor area. 3D scanning, yeah, 3D laser scanning is now a more efficient and accurate method of virtual inventory of real objects. In this method, the 3D scanner is positioned in the selected places on the object and then fires a laser beam from the rotating head, how you see in the moment. The laser beam, when it hits in a physical obstacle, bounces off it and returns to the scanner head. When we measuring the time the beam was outside the scanner, we know the distance and physical obstacle from the scanner is calculated. Yeah? During one scanning process, the beam is fired many times, obtain data, and this is what we data have is called like point clouds. Yeah? When we have this point cloud, we must processing this obtain a point cloud along with we have a parametric photos, but after point cloud processing, we can select it each plant resources. Each plant resources we selected, and we have a separate object. Yeah, we have every one object is a separate object. After scan, we do it like here. Yeah. Everyone we can separate, and when we separate this object, we can do a 3D CAD modeling. Yeah, the separate point cloud object is a reference material for this next step, which this is 3D model for a flexible applying of the our plant. Yeah. All models elements are called like factories libraries, yeah. Factory resource libraries, maybe that's better. For this, everywhere element resource can be freely placed on the factory. How we want, we can place it later on our factory. The level of details, how you see it in the write-up of this presentation, this the level of details called load factory resource can be agreed with individually with the client and maybe better or worse. Yeah. After we have these OS factory resources, can be configured in a variety of ways. We can create both full configuration resources. First, where the users can enter the values of types, varieties, revisions, unlimited numbers of parameters, such, for example, like here, a material of construction, performance, power consumption, air consumption, schedule maintenance, warranty period, and whatever you want. You can put of every one of our factory resource, or we can do a series of types our factory resource, and you can enter the value only from the possible parameters. It's how you want. And later, these parameters can go to another systems. Yeah. When we have all these resources with all information we need, these resources are set up in virtual factory according to the actual location. Here we see how, on this basic point cloud, we position 3D models to reflect the actual layout, how we see now, yeah? Everything we can position like here, okay? And later, additional, we can create an entry architectural model of our building. This, if we need this is for some our customer is necessary to do additional architectural model. In this architectural model, we can give a beam information. This beam information is good for better managing of this building in our life cycle of our factory. Yeah? In the final result of this scanning 3D, we have something like this. Yeah, this is normal point cloud. Yeah, and after we do this all steps I said before, we have normal 3D model of this factory. First, what we can do is a few of benefits of something like this. This benefits is, of course, full inventory object. In a digital, we don't must go for the factory. We have all full inventory of the object. We have planning the new layouts without visiting, of course. Yeah, potential database to main constructions of green or borrowed fields, building a new factory, change something in factory. Of course, this is ability quick to facility remove. Yeah. And expand to the next stage, because this what we say to scan this our factory is only the next step to building the real digital things. We must integrate this with our and other systems in our facility. Yeah, integration with these systems for full digital access to real data, because we have a IIoT and we have full visualization what happened. Yeah, we can visualize on a computer screen or through VR or IR. Yeah, increasing of OEE. We have a client doing increasing OEE up to 12%. Discrete mean time repaired. Yeah. Such more information to integration to another system. We, of course, can talk about this later. But today, the first and more interesting for us is easily, quickly transfer the models, separate models with all informations, all special things to the FlexSim, yeah? From the Autodesk or every another system. There is no problem how you ask first, yeah? But for us today is scan this and transfer fast to FlexSim. I think, David, please show us what we can do with something like this. Yeah. Thank you very much.
Okay, thank you, Marcin. Okay, so to start, I will do like we always do. So let's say no PowerPoint from me, and I will start to show everything in FlexSim. So we knew before about 3D scanning and what we can get out of it, but we always had an issue that the model was too big, it was clunky, it was unpractical. Basically, years ago, you will get just one big 3D model and you couldn't do nothing with it. Yeah? It was the biggest problem. So when we start talking with CAD Vision, with Marcin, and we think about this idea, okay, let's try it. So the technology went forward, and the CAD Vision has huge expertise in those kinds of projects. So we say, okay, let's meet, let's talk, let's see what we can get out of it. And we went to Panowa together with Tomek from our team, and we were thinking, okay, we will try it. It will be just big, I know, step file. It will be a few gigabytes, hundreds megabytes. We will be having a very hard time just to import it in FlexSim. And that was our initial ideas. And we went there, we sit with Marcin, with Przemek, and I think it took Przemek 15 minutes, 20 minutes or something, yeah? And he came up with one file with the whole factory, with everything, and it was like 60 or 70 megabytes. I'm like, okay, this can work. Yeah? So how can you use it? So you will get something relatively small, relatively handy, let's say, and it's okay, so let's try making simulation of it, and let's try to showcase what will be the difference. So the difference is that usually you make simulation model, let's say it's classic model. I will go in detail a little bit about what is there, but it's logistic train with some cars. We travel through the line. We build it on top of 2D layouts. Okay, everything is there. But everything is there, and there's a lot of things that you don't want to be there. You need to clean it. It's not very insightful, I would say. Okay, I know what is it, but it's a lot of things. It's even if you run the simulation, here you will see what is happening here. You can still have some hard time seeing what is actually happening here. Yeah, what am I doing here? What is where? Okay, it works. You will basically get the same result in here. Yeah, but let's say in the communication sphere and how the model is perceived, and to go back with what Alan said, how the stakeholders were going to see what is there, it can cause an issue. Yeah. So what we did here, we added to the simulation, so you can see this as a same simulation model, but in this time using the 3D scan from CAD Vision. Still, I would say it's the same model. You could say it's the same result, but I would say you can do much more with it. Yeah. So for example, maybe I will just run some stop signs. Oh, sorry, it's not this version. Give me a sec, this version. So if you run this model on the stop sign to, let's say, get a closer look on what is happening there. Yeah. So you can see the model. We can run the stop sign, and we can see what the train is doing in this particular time. You can run slower. We can see what is happening there. You can see it's much clearer what he's doing, why is he doing, why there is so cramped space. Because you can see here the train will do just very small movement, like 1 meter ahead. Because not a lot of space, it's very hard to slide the pallet inside the car, inside the wagon and train, very cramped space. You can see much clearer what is happening here. You can discuss with the stakeholders what is happening here because they can understand what we are talking about. They can understand what kind of processes we are talking about, what is happening here, and why is it there. Yeah, because it's much clearer, let's say, than you will do it just with 2D layout. Yeah? So totally different reception about what can be done here. And you can see the switch here is very fast. So you will build the model, let's say, in the same way, and you can then just create the extra layer just to see the presentation and see of what is happening here. Yeah? So as you can see, we are a few clicks away on doing something pretty extraordinary in the case how it looks, how it presents. Yeah? Especially if we are talking about stakeholders in the process. Yeah? Stakeholders, let's say the higher the stakeholders are, the less they understand from AutoCAD drawing, yeah? Because it's too many informations for them. Here, they can clearly see what is happening, how it's happened. In this case, of course, this logistic train simulation. So what we are getting out of this model is how the train works, how much time we are losing because the process stops, how many loops we are doing, how many peaks, what is the loop efficiency. It's still, you will still get, let's say, the same result. But how the model looks, how the model can sell your products or can sell your ideas, it's something completely different, and it's something on completely different levels. And this is just, of course, one of the ways you can use 3D scanning. And this is, I think, one of the huge advantages of we can see. And this, let's say, advantage of this partnership with FlexSim Autodesk that we could meet CAD Vision and we can do something like this. And now to show you, because you may not believe it, even though it's still in FlexSim, but to show you, I will open the FlexSim. That's just how lightweight these shapes are and how easily you can use it inside the model. Yeah? So if you want to import just the shape of the factory, we can see with the front. You can see it's 85 megabytes. Of course, you need to wait a few seconds for it to import, but still much shorter time than you would do it using, for example, an step file. Still, you need to resize it. Yeah, it's standard in FlexSim. The units will be always a little bit different. Yeah, but you can do it pretty fast, and then you have it. You can have the shape there. Of course, you can make it no select, so it's not bothering you at all. You can build on top of it. You can build on top of the 2D layout. You can play around with it, not a problem. But what we can see is, I think, the biggest advantage here is the approach of how this 3D scan is being made. So what we can also get from it is the shapes of individual machines. So we can get this as a one shape. Okay, it looks good as an extra layer to present. But what you also what we also do here is we have the standard processor, and we can very quickly use the machines out of these shapes also. Still some resizing to do. But you can still use it fairly quickly as a standard processor in your simulation. And so you're not getting just this big clunky 3D shape. What you have here is the shapes of individual machines, and you can use them very easily in your FlexSim. They're very lightweight. I think it was 200 kilobytes or something. Yeah? So it's, I think for us in our approach, this is something that can greatly improve, let's say, the value added of your simulation. Because you have the statistical, there are some analytic data, you do the experiment, but somewhere on the way, at the end of the way, we need to convince someone that what we did, what we calculated, is a good result. Someone needs to believe us. That believe that, okay, this layout, this project, this site, this green field is something that will work. And using this 3D scan, I think is a great method to add those value in relatively, I would say, relatively simple way. Because you're still building model in the same way. It's still the same simulation with the process flow, with global tables, everything. But what you can use here is get this extra layer. And to show that it's very reliable, you can also run in RTX, and it still looks relatively good. So you can see it's, maybe I will need to add some extra lighting for it, but even RTX, it will look relatively good, and it's not very heavy on processing on the graphics. So I would say, great addition, and I'm happy that thanks to joining with Autodesk, we can do now things like this. So we always knew that the FlexSim is, let's say, the best analytical tool, best simulation tool in the market, and now I would say we can also make it best looking. I think this is something that is kind of important, especially when you want to convince stakeholders that our idea is the best. I won't say optimal, best idea. Okay, I think this is it. This is little showcase. Do you have any questions about it?
Yeah, this is the time for questions to Dawid and Marcin. Yes, so I give you a microphone, maybe.
Okay, so probably to Marcin, how much time did it take to do the reverse engineering with the scan model?
This one facility?
Yes, yes.
It was about 3,000 square meter, how I say. We scanned this for 3 weeks, but only Saturday and Sunday, yeah, because they working. That was 6 days of scanning and prepare this do 2 or 3 engineers about 1 month. Yeah.
Okay, I was asking about the geometry that you made basing on the scan.
Yeah, that was about after scan. 6 days for scan and 1 month for 2-3 engineers to do all geometric or all of these objects like a.
Okay.
Yeah.
And what is the output file? The type of it?
What do you want?
It can be whatever you want.
Step, IGs, I don't know, FB, OGA, what do you want? Autodesk can give to CATIA, no problem, to SolidWorks, to Creo, there's no problem. We can do it, what do you want?
I think from FlexSim perspective, we use the FBX. It was, I think, the smallest and the fastest to import and easiest to handle.
Yeah, of course, if you want this data to another system, like I say, IoT or ERP system or another, we can do a CSV for this. Every word you want, we can do it with this.
Okay, great, thank you.
Okay, thank you.
Same thinking, same questions. Thank you.
Any of you have any more questions? So it was a quite innovative presentation, and thank you for a great presence. Applause, yeah.